Hello, it's me again, Nekomat-senpai. For today's video, we're going to continue our lesson on areas under the normal curve. So we are now on case number 2. But before that, I would like to correct my statement. I said in my previous video that there are 5 cases, but there are actually 4. Okay, 4 only. Okay, so I don't know where they get the extra one. Okay, anyway, so for case number 2, so here are the keywords. Remember in our case number 1, the required area is greater than z. This time, the required area is less than z. Now, take a look at these figures. So you have the figure number 1, wherein the given z-score is negative. So it is less than z, so that means the shaded region is to the left of z. So this is the area that you need to solve or to get. Okay, in this case, now if you have a negative z value, told you before, there are it's either you add or subtract 0.5 not to get that area. So for negative z, since this is less than 0.5, or it didn't reach the half of the normal curve. So what you're going to do is to subtract, because it is less than 0.5, subtract. And what you're going to subtract is, okay, let's use the red color. What you're going to subtract is 0.5 r 0.5. I'm having this one, the half. This is 0.5, right? Okay, this side here. And the area on this part from 0 to negative z. So you subtract 0.5, this one, and this area here, this one I shade, to get this area. Okay, so that's how you solve when you have your given negative z. So if you have positive z here, so that's to the left of z, so this is the area that you need to get. So you can see that this area or this region here is larger than half of the normal curve. So that means if you solve for the total area, you're going to add this part 0.5, or the 50% of your normal curve, and this area here from 0 to z. Okay, to get the total area. Okay, this one. So 0.5 plus this. Okay, so that's how we're going to solve. Okay, now let's have examples. So number 1, find the area to the left of z equals negative 0.56. So step number 1, we draw the normal curve. So I already have the normal curve. Step number 2 is you locate the z-score or z value. So this is negative 0.56. So you're going to take a look at this part. So you locate negative 0.56. So that is between 0 and negative 1. So let's just say if this is negative 0.5 sa tunga, or at the middle. So we're going to put here negative 0.56. Okay, there you go. Then you draw a line through the z-score. Okay, then you shade the region. So it is less than or to the left. So you say shade the left side. Okay, so this shaded Oh, sorry. Okay. There you go. Okay, there. That's ready to solve. So again, in this case, you need to subtract. To solve this one, you need to subtract 0.5. Okay, fine. The one with the orange marker. And minus this part here, this one. So that's the area from 0 to negative 0.56. So that means we need to get that area using the z table. So in our z table, we locate 0.56. So again, first two digits, you have 0.5. Then the last digit is 6. So you match it, 0.5, 0.5, then 6, 0.06. So that is 0.2123. Okay, solve for that. So 0.5 minus 0.2123. The answer is 0.2877. Well, that means the probability that z is less than 0.5677, or you're going to multiply it by 100, so you'll get 28.77%. Next, example number 2, find the area below z equals 2.45. Okay, so 2.45, it's near 2.5, so I'm just going to write 2.45 here. Okay, so draw a line below, so that means on to the left. So this is the area that you need to for. Okay, now you can see that it's greater than 50%. So we're going to add 0.5 and okay, let's use this yellow one. Okay, so you add, this is the 50%, and this area from 0 to 2.45. So let's solve that first. So using the z table, you need to look for 2.45. So 2.4 first, two digits. Okay, you have here. Then where is the 5? Okay, so 5. There. Okay, so 2.45. Its area is 0.49. It's add to 9. Okay, so as the answer, that's 0.9929. So the probability that 2.45 is, now if you're going to write that to percentage, multiply it by 100%, so that's 99.29%. Okay.